Welcome to the magnesium oxide lab. Today you guys are going to take pure magnesium and oxidize it in a crucible. You're going to measure the amount of mass change as the magnesium oxidizes, or once it's oxidized, and then from that mass change you'll get mass ratios, which you can turn into mole ratios using percent composition, and then calculate the empirical formula. Step 1 of the lab says measure blank grams, or step 2, measure blank grams of the ribbon and put it into a loose ball. But we're not going to have you measure mass right away. We'll have you measure length first. So measure 25 centimeters, and to do that, we may have these cut for you already. If not, put your magnesium strip on a ruler to 25 centimeters and then bend it at 25 centimeters. With a couple bends, it'll break. There's your 25 centimeters. Then take the magnesium and a pen or a pencil and coil it. You want it to be in a coil so that it'll fit inside of the crucible and still have air in between the layers of the coil. All right, that looks good. Let's find out the mass of this. Here I'll zero the scale. Take my coiled 25 centimeters of magnesium, cut my hands over the scale to keep the wind from blowing on it, and 0.332 looks good to me. Then come back to the lab and write in your 0.332 grams or whatever mass you have. Don't write down my mass, you'll have your own mass. Your lab setup today includes a crucible top, a paper clip, and a clay triangle on a ring stand. And the clay triangle just holds the crucible in place so we can heat the magnesium. Now, heating the magnesium raises the energy of the reaction mixture to its activation energy. Now, when I say reaction mixture, I mean the magnesium and the oxygen in the air. And by raising it to its activation energy, we should see a synthesis reaction between the magnesium and the oxygen. At this point in your notes, go ahead and write that synthesis reaction down. Your crucible may be dirty. Ooh, this one's perfectly clean, but it may be dirty from last period. If it is dirty, don't get it wet. Just wipe it out, and then there'll be dust in there. You can dump the dust into the garbage, and then maybe blow the rest of the dust out, and you should have a nice, clean crucible. Yours probably won't be this clean. This one looks brand new. Before you oxidize your magnesium in here, you need to heat this up and weigh your crucible and top, dry and hot. From a previous lab this year, you learned that the porcelain's porous, there's water in there. We can drive the water off by heating it up and evaporating it. That will lighten the porcelain so that it's the same mass before and after the oxidation of the magnesium. That controlled variable is very important. So to dry it out, put the empty, make sure it's empty, porcelain. So I've been heating my crucible and my crucible top for a couple minutes. It should be dry now. So go ahead and turn off the gas, and you'll have crucible tongs. The reason that we put a paper clip on the crucible top is so that it's easy to get that off of there. Also, the reason that there's a diamond shape is so that you can pick up your crucible. If you squeeze too hard, the crucible is going to pop up out of there, fall to the ground, and shatter. And you'll have to start your experiment over. So you might want to practice this or come and get some heat resistant gloves and wear those underneath this so you can catch it if it falls. So here I am back at the scale. Re-zero it. This time you've got the cardboard on top to protect the scale from the very hot, dry, lighter crucible and crucible top. Gently place this on the cardboard and get your mass. All right, that's the mass that goes here. Dry and empty crucible lid. You might even want to make a note here that it's got to be hot to be dry, so you've got to cook that first. The next two lines on the lab are pretty easy to figure out. Letter B is just letter A plus the mass of your magnesium you wrote down here, and letter C is the same mass. Now we got to cook the magnesium. I'm using my crucible tongs to hold the paper clip, and I'll take my magnesium and miss. I'm leaving that in, and drop that into the crucible. And I'm just going to tilt this a little bit so you guys can see in there. Place the top back on and light your Bunsen burner up. Now the lab instructions say don't put the top on until you see the magnesium start to react with the oxygen in the air. And this is where you can take the lid and just put it aside and peek in there. And keep peeking in there until you see a reaction begin. You'll see it begin because the magnesium will start to glow. So we're waiting until the magnesium glows. Your reaction will start a little faster if you take the top completely off and just hold it there with your crucible tongs, waiting to see that magnesium start to glow. Now the magnesium starts to react really quickly, suddenly, and that's why you want to hold the top over. My magnesium suddenly began to react, and I just put my top all the way on the crucible. That restricts the oxygen flow and controls the rate of the reaction. We can take a peek and we can see the glowing magnesium inside. Now, what I'm going to do is, I don't want the magnesium oxide to spatter out into the room or react too fast. So I'm going to leave my lid just slightly ajar, and the lid will act like a damper in a wood stove, controlling the oxygen flow to the magnesium ribbon. This is a good time to find this section on your lab and make a little drawing of a crucible with the top slightly ajar. It looks like a jaunty beret on an acorn. And that's just to control the oxygen flow into the crucible so that the magnesium oxide doesn't react too quickly. Our magnesium's been reacting with the air, producing magnesium oxide for about a couple of minutes now. We're just going to take a peek. Oh, let some more air in. If you let more air in and you see a quick brightening, you know that the reaction is not done yet. And keep doing that over and over again until you don't see any more flashes. When you take the lid off and it no longer flashes brightly and just glows orange, you can tell that the magnesium oxide produced or that reaction is complete, and we've made all the magnesium oxide we're going to make. So you can put the top back on, turn off your gas, and let your crucible cool for up to 5 minutes. Cooling your crucible is really important to make sure that you don't burn the cardboard that's on the scale. We're back here at the scale, zero it, place the crucible back on the scale very carefully with your crucible tongs, and we can see our mass has gone up. That's where the total mass would go. I think it was 40.057. Again, use your own data, but we see that we have an increase in mass here. The synthesis reaction has taken oxygen from the air, added it to the magnesium, and now we have a heavier compound, or more atoms in the crucible. You can use subtraction to find E, and also to find F. Your last step before you do all the calculations that are in the lab is to take the top off and to clean the magnesium oxide out of here. And my crucible is still too hot to touch, so I need to wait. Once it's cool enough to touch, you can dump this in the garbage. This is just ash. And then take your paper towel for next period, wipe out the crucible, place it back on the clay triangle, and next period should be good to go. Thanks everybody, have a good lab.